Today's lesson focuses on writing linear equations given only 2 points. Our essential question is, how do you write linear equations given 2 points? So if we're going to write an equation and all we have is 2 points, we are trying to write it in slope-intercept form, and so we need 2 pieces of information. We need a slope and we need a y-intercept. Well, we already know how to find slope from 2 points. A reminder of that formula is that slope can be found from y2 minus y1 divided by x2 minus x1. So we already know how to find slope from 2 points. The next challenge is going to be how to find the y-intercept of a line if all we have is 2 ordered pairs. Well, one possible way to do that is to rearrange the slope-intercept formula of the line for b so that we now have a formula to plug in some information every time and just find out b, the y-intercept. So here it's telling us, given y equals mx plus b, solve for b. What they are saying is rearrange slope-intercept form to isolate b, get b completely alone on one side of the equation. So in order to do that, we are going to need to move mx to the other side of the equation. Well, we don't want to break apart m and x because we are not trying to isolate either one of those variables. We are trying to move the entire term mx to the other side of the equation. Then we will have b alone. Since mx is positive, being added to the term b, we now know that the subtraction property of equality allows us to subtract mx from both sides of the equation in order to isolate b. A positive mx minus mx will cancel itself out and is now on the other side. So the question over here is, can I combine these two terms? Well, y and mx are not the same variable, it is not the same term, and so I cannot put them together. All we can do is write what we see. Y minus mx is equivalent to b. So if we write that the other direction, b is equal to y minus mx. So this is not the only way to approach these problems, but this is one of the ways. Now we have a formula every time we know the slope and an x and a y coordinate to plug in and find the missing y-intercept. That is just a new skill added to our ability to find slope from 2 points. So let's test this out and see how it works. Our first example is the 2 points 1, 4 and negative 3, 8. Our goal is to write an equation that these 2 points fall on, of the line that these 2 points fall on. So we know we're trying to do slope-intercept form. So we need a slope and a y-intercept. So we're going to find slope first. We know we've got x1, y1, x2, y2. And we need to find the slope. We know it comes from y2 minus y1. So on top, I would have 8 minus 4. On bottom, we've got x2 minus x1. So we've got negative 3 minus 1. So our numerator, 8 minus 4, gives us 4. Our denominator, negative 3 minus 1 gives us negative 4. And I always want to reduce, if I can, 4 divided by negative 4 is negative 1. So our slope is negative 1. We have part of our equation so far. We know that the equation is y equals negative 1x, but we're still missing our y-intercept, our b value here. We just rearranged slope-intercept form in order to make up a formula where we could plug in information and find b. We said that b is equal to y minus mx. Well, y, m, and x are information that we now have. The m, obviously, is our slope, so I know that's what m is, but the y and the x come from either one of the coordinates. I could use this first point and use this x and this y value, or I could use the second point and use this x and this y value. Since both points lie on the line, either one of them should always work. Okay, so I usually try to find the ones with smaller numbers or less negatives. It doesn't matter, but we want to take the path of least resistance if that is an option. So I'm going to use this first ordered pair, 1 and 4. So I'm saying that the x value is equal to 1, the y value is equal to 4, and the m value is equal to negative 1. plugging those in for y, m, and x so that I can find out b, the y-intercept. So we've got b is equal to y, which is 4, minus m, which is -1, times x, which is 1. Following order of operations, we need to multiply before we subtract. So b is equal to 4 minus -1 times 1 is -1. So 4 minus -1, that double negative is really like a plus. So b is equal to 4 plus 1, which is 5. We have our slope. Now we have our y-intercept, and we can complete our equation. The y-intercept is a positive 5. So the equation of the line that these 2 points lie on is y equals -x plus 5. You can write -1, it means the same thing, or you can also see it as just -x plus 5. Example 2, we're trying to do the same thing. We are trying to find the slope and the y-intercept so that we can write the equation of the line. So we will find slope first. I've got y2 minus y1, so I've got 14 minus 12, divided by -2 minus -6. So this is going to tell us our slope. Our numerator, 14 minus 12, is 2. Our denominator, -2 minus -6, is really like a -2 plus 6, which comes out to be 4. 2/4 continues to reduce to 1/2. So far we know our slope is 1/2. Now we have to find our y-intercept. We know that b is equal to y minus mx. So we're going to pick either one of these ordered pairs. It does not matter. Since I used the first one last time, I'll use the second one this time to prove to you you can choose either one. So I've got an x and a y value. So m is 1/2, x is -2, y is 14. I'm going to plug these 3 numbers into this formula to find out what b is equivalent to. So b is equal to y, which is 14, minus m, which is 1/2, times x, which is -2. Once again, I have to do the multiplication piece first. So b is equal to 14 minus 1/2 times -2 is -1. 14 minus -1 is like 14 plus 1. So b is equal to 15. We have our slope. We have our y-intercept. So we need to plug them into y equals mx plus b to write the equation of the line. So y is equal to 1/2 x plus 15.